Good evening. Am I audible to you? Right. Okay. So, which chapter we are doing? Synthetic fibers and yeah, right. Synthetic fibers and plastic we are doing. No, right. So, synthetic fibers and plastic. This already introduction we have done. So, generally what are the fabrics, the clothes what we use, what we wear, they are called as the fabrics, and these fabrics are made from the fiber. Yes, this already we discussed. Polymer, poly means what? Many, mer means unit or part. So, many units or parts will join to form a big chain like structure, which is called as a polymer, right. So, here you see this all we discussed, but once again, so the clothes which we wear are made of fabrics. Okay. So, whatever the clothes we are using, these are called as the fabrics. The word polymer is coined from the two Greek words, the poly and mer. It is taken from the two Greek words. Okay. Poly means what? Many. Mer means what? Unit or part. Okay. So many units or parts joined together to form a polymer. So, polymer is a substance composed by many repeated similar subunits. Okay. So many things will join together, small things will join together to form a long chains. Okay. Like that. The use of polymers is in the manufacture of plastic buckets, cups, saucers, children's toys, packaging bags, synthetic clothing material, automobile tires, etc. So, here polymers where we can use in those all those things like plastic buckets, cups and saucers, children toys, packaging bags, synthetic clothing material, okay, this one. And the polymer or the backbone of the four major industries, one are called as a plastics, elastomers, fibers, paints and varnishes. So, mainly this polymers where we can use mainly means they are used in the plastics, okay, and they are used in the elastomers means elastic which have elastic nature like rubber related materials. Fibers means what? Threads and ropes like nylon ropes, and paints and varnishes. Okay. In all these things we use this synthetic fibers. Is this clear to you? So, you can see here these are the fiber, these are the thread fibers, okay, fabrics, these all things. So, take the screenshot of this one. Done? Right. Now, see, these are the classification of polymers. So, polymers can be classified in different ways, in many ways. Okay. So, like polymers they are classified based on the occurrence means what? How do they available, and based on the structures, how they are structures like linear, cross turn, branch turn something, and molecular forces based on the force of attraction between the molecules, and based on the thermal behavior means what? With the heat, how they behave with the heat. So, there is so many types of classifications are there. So, see here based on the occurrence, this already we discussed in the last class. Based on the occurrence way, natural polymers are there, synthetic polymers and semi-synthetic polymers. Natural polymers means what we discussed in the last class, which are available from the plants and animals. They are called as a natural polymers, example cotton, wool, etc. And synthetic polymers which are completely made man-made like petrochemicals. The most important one what we discuss is nylon. Okay. And then come to the semi-synthetic polymers. Semi-synthetic means what? The material which is obtained naturally, but that is processed by human beings and it is made into fibers. So, such is called as a semi-synthetic fiber. Example I said the rayon. Rayon is also called as a artificial silk. This already we discussed, right. So, in the last class we discussed up to here based on the occurrence natural, synthetic and semi-synthetic polymers. So, today we are going to discuss based on the structures, molecular forces and thermal behavior. So, based on the structures again they are classified into three types called as a linear. Okay. Linear means what? Straight. Linear means what? Straight. Okay. Yeah. So, straight polymers, branched polymers, Okay, along with the straight some branches will be there, and crossed polymers means two or more layers. Okay, linear polymers they joined, so that's called as a crossed polymers. Based on the molecular forces means the force of attraction between the molecules from which they are made up of. So they are classified into four types called as the elastomers, fiber, thermoplastic and thermosetting. Okay, based on the molecular forces. And last and final one based on thermal behavior, thermal plastics and thermosetting plastics. So this can be thermoplastic means water which on heating easily melts and they can be deforms. So whatever we want to make it into different shape, we can make them. And thermosetting means water, they are very hard, even on heating also they do not melt. And of course these two we can study here only. So okay, we are not going to study specially that one. Of course there is a based on the thermal behavior, these are there, this we study here only. Okay, so these are the classification of polymers. So we can classify the polymers this many ways, based on occurrence, based on structure, based on molecular formulas, based on thermal behavior. Is this clear to you? Yes, Avinash? Take the screenshot of this one, very important this one. The total lesson here only it is there. Right. So in the last class we discussed about the classification based on the occurrence. So natural polymers, synthetic polymers, semi-synthetic polymers, natural, synthetic and semi-synthetic. Okay, so this notes is missing. Okay, however we discussed. Now second one today we are going to discuss, that is the classification based on the structure of polymer. Structure means shape. Based on the structure of polymer, how these polymers can be classified. Polymers are classified into three types. How many types? Three types. Based on what? Based on structures. One are called as a linear polymers. What are the first one? Linear polymers. Second one are called branched chain polymers. Okay, branched chain polymers. Third one is what? Cross-linked. Okay, or network polymers. Like this, total three types of polymers are there. Okay, linear, branch chain polymer and cross chain polymer. So based on the structure, the polymers are classified into three types. Okay, you can see on the picture here very clearly. Okay, so linear polymer, one by one we discuss. These polymers are similar to long straight chain. Okay, linear means, as already told you, linear means what? Straight. Okay, so they are bonded one with other one. Okay, they combine with each other and form a long chain like structure. Okay, so here these polymers are similar in structure to long chain which identical links are connected to each other. So here you see this one. Okay, this is the first unit, this is called monomer. These all monomers, these all are monomers. Okay, these all are monomers. So these monomers, one joining with other one. Okay, this joining with this one, this joining with this one, this joining with this one, this joining. So like this, they all are joining. Okay, connected to each other. Is this clear? And every part here it is called as monomer. Mono means what I said? Single means one. Mono stands for one and mer means part or unit. One unit, that is called monomer. So similar type of monomers will join one by one and it form a long chain. Okay, so see these polymers are similar in structure to long chain, okay, which identical link connected with each other. The monomers in this are linked together to form a long chain. What monomers? Monomers means, mono means what? Single, mer means unit. So single units, like this, so many single units will join one by one and forms a long chain. And these polymers have high melting point and higher density. So to melt them it requires some more temperature. So they have the high melting point and the density. Density means what? Mass by volume. Already we discussed. So the density of this one will be more. And example for this one is PVC. See, this is also very important. PVC means what? Polyvinyl chloride. Okay. So this polyvinyl chloride where we use? In the electric cables and pipes. Okay. Electric cables and pipes. We use the PVC pipes. You can see in the TV advertisements also. when it comes to the water pipes and electrical pipes. So they discuss about they give the advertisement of PVC. PVC means polyvinyl chloride, PVC pipes. So these PVC pipes are examples for the linear polymers. What they are? Linear polymers. Is this clear to you? Chalo, take the screenshot of this one also. Right. So that is about the linear. Linear means what? Straight. So see like this, straight. Okay. So here also you see this is a straight. Okay. So like this is no links are there. No links are there. Right. So there are no branches, no links, straight. So this is called as a linear polymer. Okay. Now then come to the second one, branch chain polymer. So branch, you know the branch for the tree. If it is a tree, it will be there like branches will go like this. You know the tree, no? Yes. For tree, what will be there? Branches will be there. Yes or no? Branches will be there. Okay. So how the branches will be there for the tree? Similar to for your linear polymer, some branches will be joined here. Okay. Some other monomers will join to form branches. So this type of monomer polymers are called as a branch chain polymer. Clear? So very simple. So see here, the structure of these polymers like branches originating at random points of a single, see, random points means what? Not at one particular order. So here you see after 1, 2, 3, 4 here we are getting one, okay, chain here like this, okay, like this, different places we have a branches. There is no particular order. Random means what? There is no particular order is called as a random. Okay. So they have the, for the chain, okay, linear polymers, okay, in different middle, what happens? Some branches will join, okay, randomly. So such is called as such branches are called branch chain polymers. Monomers join together to form a long chain with some branched chains of different length. See, monomers join together to form a long and straight chain. See, first this is the monomer joining, okay, with each other and forming the long chain, long and straight chain with some branched chains of different lengths. So here some different chain lengths, okay, something like this, different chains, okay, will be attached to this one. So this type of monomers, a chain with the different branches is called as a branch chain polymers. Okay. So as a result of these branches, the polymers are not closely packed with each other. So see here one branch is there, here one branch is there, lot of gap is there. Okay. So they are not closely packed with each other, they are not very close, come close to each other. So due to that what happens? They have the low density and low melting points. If they are very closed, then what happens? So very close to each other, so many things will be there in the small area, so the density will be more. So as they are very far from each other, so a lot of gap is there, volume is more and mass is less, so therefore the density will be low. So generally branched chain polymers are low density, they have the low density and low melting point, means very quickly they can melt. So where we can use? So we can use a low density polythene, okay, which is used in the plastic bags, okay. So the plastic bags, plastic containers very easily which can be used. In such cases they use this branched chain polymers. Is this clear to you? So branched chain polymer is nothing but a what? Monomers will join to each other to form a long chain. To this long chain some other branches also will be there. So due to these branches they do not come close to each other, so there is a lot of gap is there. So volume will be more but mass will be less. So due to that they have the low density and low melting point. Is this clear? So that these are the, and these are low density polythene. Example is, this is example. So example is low density polymers, polyethylene, okay, and generally they are used for the plastic bags, okay. So take the screenshot of this one also. Taken? Right. Now last one, that is what? Cross-linked, okay. So in the cross-linked polymer you see, cross-linked, say this is one linear polymer, this is another linear polymer, this is another linear polymer. Now these linear polymers are joined with some branches. Okay, so they joined here. Okay, cross. So like this joining. So like this, linear polymers are joining. Okay, with each other with some branches or crosses. This is called as a cross-linked polymers. So cross-linked or network polymers. These are called cross-linked or network. Okay, polymers. In this type of polymers, monomers are linked together. See, monomers are linked together to form a three-dimensional network. Three-dimensional network means what? Which has a length, breadth, and height. So this is a three-dimension structure. The monomers contain strong covalent bonds here, as they composed with bifunctional and trifunctional in nature. So they have the strong bonds out there. The force of attraction between them is very strong. Why? Because they have the strong covalent bonds. You will learn in the higher classes about the covalent bonds, ionic bonds, metallic bonds. There are three types of bonds out there. Okay. Now I am not going to discuss that. So there are three types of bonds out there, which are called as the ionic bonds and covalent bonds and metallic bonds. Okay. So in that term, here they are linked with what? Covalent bonds, and these covalent bonds also very, very strong. So strong covalent bond. So bond means what? Which is binding. Binding means what? Which is holding. So this is one linear polymer, and this is one linear polymer. Among this one, some cross, some branches are there which is holding tightly with between each other. Okay. So such type of polymers. So these polymers are brittle and hard. So here they are brittle and hard. Example is bakelite. So bakelite is nothing but, when you for your household, the switches will be there, no? Okay. So switches, the strong switches what we are using for electric board. So that switches are made up of this bakelite. Is this clear to you? And melamine also. Melamine is where we use, the cooker handles and pan handles will be there, no? Cooker handles are, cooker we boil the rice and so many vegetables, hard vegetables like potatoes and so many things, so that becomes very, very hot. Okay, for that there will be handles will be there. Yes or no? These handles, even if you hold the handle also, nothing will happen to you. Yes. So there we use this type of polymers. Is this clear to you? So these are called cross-linked or network polymers. Take the screenshot of this one also. Right. So this is the second type of classification. First type of classification is based on what? Based on the source from where they are available, based on the availability, occurrence. First type of classification. Okay. Natural, synthetic and semi-synthetic. That is first type of classification. Okay. This is second type of classification. This is also classification of polymers, but based on what? Based on the structure. Based on the structure. So based on the structure, they are classified into three types called linear, branch chain and cross-linked or network polymers. Clear? And the same examples will be repeated for all. Don't think that all are same example. All are polymers only. Here whatever the example we see in the previous also you have seen. Okay, like nylon, cotton, terracotta, this all. So the same type of examples will be repeated here also. Is this clear? Now, so second is what? Based on the structure of polymers. Now last and final one, third one. Third and fourth one is also there, but fourth one is a part of the third one only. Okay. So that's what, fourth one is also there. Okay, we check that one. So based on the mode of polymerization. Now this is one important word, what is called polymerization. Polymerization means what? Poly means many. Mer means units. Merization means joining. Okay. So the meaning is what? So many large number of monomers, okay, they are joining with each other. So the process in which is large number of small units are joined together to form a giant unit, means giant molecule, means bigger molecule, is called polymerization. That is the definition of polymerization. Okay. So polymerization definition is given here. Yeah, it is given, but still in a simple sentence I will write the polymerization definition. Polymerization definition can be defined as, okay, a large number of Okay, small units. Small units means what? Monomers. Monomers, okay, join together to form a giant molecule. Giant means what? Very big. Okay, a giant product also you can say. I am writing giant molecule is called polymerization. So this is the definition of polymerization. Very important definition, this one, polymerization. Polymerization is what? A large number of small units, small molecules will join together to form a long chain, okay, big chain. That is called as a polymerization. Is this clear to you? So how can the polymerization takes place? So polymerization generally it will takes place in two methods. How many methods? Two methods. One is called addition polymerization. Second one is called condensation polymerization. Okay. First one is what? Addition of polymerization. Second one is what? Condensation polymerization. Very simple, in the name itself it is there. Addition polymerization means what? This small molecule directly they combine, and again one more molecule will come join to this one, one more molecule will come join to this one, like this one are continuously joining with each other. Okay, this type of polymerization is called addition. Addition means what? Adding. Okay, so that is called addition polymerization. Then second one is what? Condensation polymerization. What is condensation polymerization? Condensation polymerization means what? Here one molecule will be there, here one molecule will be there, but when these both will combine, from this molecule, okay, from this molecule, one atom or group of atoms will come out, and from this molecule also one atom or group of atoms will come out, and from those, see, for example, this is 5 atoms are there. Here 5 atoms are there, like example I am telling. So when these both are coming, then what happens? This molecule drop out from here, this atom drop out from here. Now these, okay, remaining will join here. So when these are joining, some, okay, atoms or group of atoms will, okay, removed from the both the atoms, both the molecules. So this process is called condensation polymerization. What it is called? Condensation polymerization means what? From here one small part will break, from here one small part will break. After breaking these two parts, this both will join. Okay, this is called condensation polymerization. Is this clear to you? Okay, so that is called condensation polymerization. So when two molecules will combine, okay, so that is called condensation polymerization. So when two molecules will join, from this some other atoms or group of atoms will lose. Generally when two molecules will combine, so from that water molecule, okay, sometimes what happens is small molecules like water, okay, will removed, water will be removed from this molecule will join, from this water molecule will be removed, and remaining part will join. This is called condensation polymerization. Addition polymerization, nothing will lose, okay, one will join directly with other one, and this one join with other one, this one join with other one, continuously joining, nothing is lost, nothing is removed, okay. But condensation polymerization, what happen? Some, okay, molecules will, okay, lose, and then they will join. This type of polymerization is called condensation polymerization. So for addition polymerization, example is polythene, okay, plastic cover, polythene covers. For condensation polymer example is nylon. What is that? Nylon, okay. So see here now. So polymerization is a process in which monomer molecules are react together to form a chemical reaction, form a polymer chain, okay. So here polymers, based on polymerization, two types are there. One is called addition, second one is called condensation. See, in the addition, what happens? By the addition of monomers. So, one monomer, this is a one monomer. For example, you think, okay, this is one monomer and this is joining with directly with other monomer. This is joining with other monomer. So, like this continuously joining. But here what happens? So, for example, this is one molecule. Okay, this is one molecule and this is one molecule. When these both are joining, some part of this one will be lost. Okay, some part of this one will be lost here. Okay, so like this, again they are joining, some part will be lost. So generally they lose the water molecule. Okay, so the meaning is what? For example, simply I would like to say here, from here it lost one hydrogen molecule, from here OH molecule, again from hydrogen molecule, from OH molecule, from hydrogen molecule, from OH. So H and OH forms water, H2O, H2O. So like this. Okay, they loses the, okay, see a polymer, condensation, polymerization, elimination. Elimination means what? Removal, elimination. Elimination of small molecules such as water. So this is formed by the elimination of small molecules like water, and remaining will be joining. So that is called as a condensation polymerization. Is this clear to you? Yes. So take the screenshot of this one. Right. Then come to the now just in detail. So addition polymers means what, and condensation polymers means what? Addition, see, where is, just now I told you, know, addition. Addition means what? This type of polymers are formed by the repeated addition of monomers. Repeated addition of monomer molecules. Monomers, they are joining and continuously forming a chain. No elimination of anything will be there. Okay, so such type of okay, is called as the addition polymerization. Generally, this polymerization formed from the double and triple, or we can say unsaturated compounds. This addition polymerization takes place, okay, among the unsaturated hydrocarbons, unsaturated compounds it will take. Okay, example, it is say polyethylene. Say polyethylene, polythene, plastic cover. It is made from the molecule of ethene. It's made from the molecule of ethene. So here between the ethene, here you can see here one is equal to, like is there. It is not is equal to. That is a double bond. What it is? Yes, Avinash, are you there? So here one is equal to, can you see here? That is not is equal to, that is double bond. Two bonds are there like this, one, two bonds are there like this. Okay, so two bonds, so that is called double bond. So here this is unsaturated. This is what? Unsaturated, which have double bond and triple bond, they are called as unsaturated. Which have single bond, only one bond is there, only single bond, then that is called as a saturated. So here you see, here this is ethene. Like this, many ethenes means poly. Poly means what? Many ethenes. Then joining to form polythene. This is called polythene. This is called only ethene. This is monomer. This is polymer. Between the difference you see, here double bond is there. Here single bond is there. Did you understand the difference? So this is called addition polymerization. Addition means what? Just joining, adding one over the other. Okay, nothing will be eliminated, nothing will be removed, nothing will be lost. So that is called addition polymerization. Example is polyethylene. Okay, now then come to the next one, is a condensation polymerization. Condensation polymerization is formed by the combination of monomers. Here also monomers will combine, but with the elimination of small molecules like water, alcohol, etc. So here also, this also monomers only. Monomers are joining with each other, but while joining, they are losing some molecules, small molecules like water, alcohol, etc. By joining, by elimination, by loss of molecules, small molecules, they are joining. So this process is called as a condensation polymerization. Condensation polymerization. Okay. So condensation polymerization example, say nylon 66. What do you write? Nylon 66. See, here most important thing is that how this nylon is formed. Nylon is formed from the two substances. So here you see what are the substances. See how much big name is there. How to read. So this is called hexa. Hexa means what? 6. Methylene, okay. Hexamethylene means what? 6 methylene ions along with the di, di means what? 2 amine, okay. This is all one product only, one polymer, one monomer only, okay. This one is combining with adipic acid. Which acid? Adipic acid. These both are joining by loss of water molecules. See, where molecules of water are eliminated in this process to form the nylon 66. So this is very, very important. Let's see how much big name is there. Can you see here? The name of the compound is what? Hexamethylene diamine. You have to read like this. If you say continuously, you will be confused how to name it. Okay, so you have to split it. Hexa means what? 6. You know, like mono means single, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, none means 9, and dec means 10. Do you know these all things? Okay, so like this, when the molecules will combine by losing of water molecules or small molecules, okay, they form a big molecule, means polymer is formed. That process is called a condensation polymerization. Is this clear, Avinash? Chalo, take the screenshot of this one. Right. Now, this is the last and final type, classification based on the molecular forces. So, here you see, for example, okay, this cloth is there. If I hold this and apply the force, so what happens? Whether it is tear? No, it will not tear. But sometimes some clothes, maybe if I do like this, they can tear. Yes or no? So because these are strong and they are not strong. Okay. So why they are strong? Because there are some force of attraction is there. Some force of attraction is there. So that force of attraction is called molecular forces. What they are called? Molecular forces. Okay. So for example, you say, for example, if you take one metal rod and you try to break it, it won't break. But if you take one plastic rod, you try to break it, it will break. Okay, but why? Because here the force of attraction is small in that one, less, and in the iron rod the force of attraction, molecular force, is more. So that forces are called the molecular forces, and based on the molecular forces, the polymers are classified into 4 types. So how many types? 4 types. Okay, one are called elastomers, second is called thermoplastics, third one is called thermosetting plastics, fourth one are called fibers. Okay, so here you see now, intermolecular forces are the forces that hold atoms together within a molecule. So intermolecular forces. So there are some forces of attractions are there. These forces of attraction are hold the molecules together, atoms and molecules together. This polymers, strong covalent bond, join the atoms with the individual polymer molecules. So there is some strong bonds are there. Okay, strong force of attraction is there, which joining these monomers to form the polymers. So based on the strength of this molecular forces, they are classified into 4 types. So how many types? 4 types. One are called elastomers, second called thermoplastics, third one is called thermosetting plastics, fourth one are called fibers. So now let us see elastomers. Elastomers, in the name itself it is there, elastic. Elastic means, you know? Yes, Avinash? Elastic means what? Like a rubber band. So when you pull it, so what happens? It gets stretches. So that are called elastomers. Okay. So see, elastomers are the rubber like solid polymers. They are elastic in nature. Elastic in nature means what? When we say elastic, we basically mean that the polymer can be easily stretched by applying the forces. Clear to you? So example, we can see this in the rubber band. This is called elastomers. Okay. Then thermoplastics. Thermoplastic means most of the plastics are thermoplastics only. Okay. So most of the plastics what we see, there are thermoplastic only. For example, this pen is there. This is also thermoplastic only. If I put on the candle flame or like any flame, what happens? It melts. Yes or no? So which melts on heating, they are called as a thermoplastics. So thermoplastics on heating, they become soft and they can change their shapes. So such type of plastics are called as a thermoplastics. So here these polymers when heated are softened, thick fluid means like liquid, like they become, and hardened when they are allowed to cool. So when you heat it, they become soft and they melt. Again when you cool it, they become hard. So such type of, they do not contain any cross bond and can easily shaped heating by using the molds. So generally if you want to make this pen, then what they do, they use a mold. You know the mold? So like this shape, mold will be there, this plastic will pour into that one, then melt it, plastic will melt, and after melting they pour that plastic into this shape of one cylinder, like it will be there, they pour that liquid inside. Then after some time they cooled and the inside they remove that molds, we can get this pen. So you know the bricks also made in the molds, you know the mold. Sometimes even Vinayaka Chauthi festival also, Vinayakan mold will be there, some will be there. In that they keep the what you say that mud, clay, and they press it and then they remove this one, so we will get the Vinayaka statue. Did you see this one anytime? They are called molds. So easily by using the molds, what they do, this type of plastic that is heated, on heating that melts and that becomes molten. When it becomes molten, then what they do, that pour in that required shape molds and we can get that shape. So a common example is polystyrene or PVC. So that already we discussed. So this is about the thermoplastic. Take the screenshot of this one. Now next one, see thermosetting and fibers. Thermosetting means what? They are very hard. On heating also they do not melt. Just now I told you that. If you take the cooker handle, so cooker, inside we keep so many things and we boil them. So lot of temperature will be there. Lot of temperature. Water will get evaporated. Inside everything will become cooked. That much temperature is there. But we can easily hold that cooker and we can take it outside with the help of handles. Yes or no? Those handles are very strong. They do not melt on heating. So the plastics which do not melt or which do not get deformed. Deformed means what? Their shape do not change even on heating. Such type of plastics are called thermosetting plastics. Is this clear to you? So thermosetting plastic, you see thermosetting plastic which do not get deformed. Deformed means what? They do not change their shape. Deformed or softened means they do not become soft on heating. So such things are called as the thermosetting plastics, and bakelite and melamine are examples for this thermosetting plastics. They are used for the pan handles and cooker handles and electric switchboards, etc. These are the third type. Now fourth types are nothing but fibers. Fibers means what? Like threads. So here the fibers are solids having thread like structures possessing the strong intermolecular forces. So due to this we can make the ropes. We can make the ropes, so they are called as fibers, and example is nylon and dacron. So these are the examples. So see a classification based on the molecular forces. One is elastomers, second one is fibers, third one is thermoplastic, and fourth one is thermosetting. So these are the four types of polymers. Clear? Take the screenshot of this one. So here we see, here one more type of classification is there that I am not discussing here. Why? Because already I discussed. So which one that is? This one. Thermoplastic behavior and thermal behavior. Based on the thermal behavior, thermoplastic, thermosetting. Here already we discussed, no? Thermoplastic and thermosetting. So with this classification of polymers is over. Classification of polymer is over. there is one more topic is there, that is called as a carbohydrates. What is that? Carbohydrates. Okay, so this carbohydrates we discuss in the next class. So carbohydrates and types of carbohydrates. So with this we complete our topic. Okay, so with this we complete our chapter, and along with this one we complete our total syllabus. Yes, Avinash? So you see this week means next week, next Tuesday we have a class. On Tuesday I will complete this last topic, and you know that every first Saturday, every month first Saturday we will have a test. Yes. So next week also we will have a test next Saturday, not tomorrow Saturday. Next Saturday we will have a test, and this test from all the topics, till now what we are completed, from all the topics, okay, throughout the year what you have done, all from even chemistry, physics, bio and mathematics. So I will have a test of a 50 marks paper on next Saturday, means on 5th day, 5th of March. Is this clear to you? So be prepared for that. Read once again, revise all these topics, and Tuesday we have a class. So I will take the Tuesday class, and I will complete the remaining small topic is there, carbohydrates and proteins. That carbohydrates and proteins part if we complete. So there are two more small tables will be there, that commercial users. Once you have seen that, show the textbook once. If you have a textbook, once you show. Last two tables will be there, only tables. One minute. 1 minute, just a minute. So that is one table. What is that? 1 minute slowly. These two tables are there now. So do one thing. After this table, second table, what is it? Turn the page. Once you turn the page, turn the page. So now so till here, this last 3-4 papers, once you take the photo and you keep to me. Okay, last 4 pages you keep to me. With this we complete our topic. Okay, try to post today only that last 4 pages, the tables, miss carbohydrates, from carbohydrates. Okay, I don't have the table. Apart from that, carbohydrates I completed. So carbohydrates is there with us. Okay, but the tables are not there. So once that tables you post to me. Okay. Okay then. Bye.